variables on both sides. And when I say that, I mean there's going to be a variable on this side and a variable on that side of the equal sign. So we're going to somehow figure out a way to combine those to just one side. The first step is actually the same as before. We're going to distribute and combine like terms on one side if we can. So we're just going to focus on one side at a time, distribute and combine like terms on each side. So that's what we're showing here. These two are coming together. To make that negative 3k, it's just 2 minus 5. That gives us that negative 3. On the right side, we're distributing. 3 times 1 becomes 3. 3 times that negative 2 becomes that negative 6. So we're not doing anything between the two sides. We're doing something on this side, something on that side separately. That's that first step. Combine anything that you can on each side. And then you're going to add or subtract to get variables onto one side and add and subtract to get constants on the other side. So we want to get these variables together onto one side. So the same way we did before, when you see subtracting, you're going to add, or if you see addition, you're going to subtract. You're doing the opposite of that operation. That subtraction, so to cancel that out, we add the 6k to both sides. The same way we did with a constant, now we just have a variable attached to that. But it's the same thing. Ordinarily, when you see a variable term like that, you might think to divide, because that is multiplication. But we're not just trying to cancel out the multiplying, we're trying to cancel out subtracting, that whole subtraction, so we're going to add on both sides. We're combining like terms there, negative 3k plus 6k, that's where that 3k is coming from. This 3 just comes down to the next step. Last step, almost always is going to be to divide. We're dividing away because that's multiplying. We're doing the opposite of multiplying. We divide it by 3 on both sides. That gives us 1 as our final answer. So the goal is still the same. We're trying to isolate the variable or get it by itself. The problem is now we have a variable on both sides. So you have to combine the variables to one side, move all the constants to the other side, and then in that last step, you almost always are going to divide. Alright, so we're going to do a few examples like this where we have a variable on the left side of the equal sign and a variable on the right. Before we do anything between the two sides, we're going to combine everything that we can just on one side. So all we're going to do is work on this side. We're going to distribute first. We're going to take that negative 2 and distribute into both of these terms. The 5 is not affected by that. That's going to come down. Negative 2 times 3 is negative 6. That comes down to make our minus 6 here. Then negative 2 times negative 1x becomes a positive 2x. Negative 2 times negative 1x is a positive 2x, so that comes down as a plus 2x. On the right side, there's nothing to combine there. That one has an x, that one doesn't, so we just leave that alone. We can still combine like terms on this side. We're going to put these two together. 5 minus 6 is negative 1. Nothing about the right side changed. Alright, now I've combined everything I can here. I've combined everything that I can here. So I want to combine my variables to one side. I'm going to move these to one side. It doesn't really matter which one you do. We could subtract 2x to cancel out this plus 2x. Or we could subtract 4x from both sides because that's a positive 4x. To me, it's a little bit more intuitive because I see a plus sign here. I'm going to have to cancel out that adding 2x by subtracting 2x on both sides. So the negative 1 comes down because those cancel each other out. This we're just going to subtract. We're combining like terms, so 4 minus 2 gives us 2x, and that minus 10 comes down. And now it's turned into a two-step equation. So I'm going to box that 2x and cancel out the thing that's outside of that box, that minus 10. I'm doing the opposite of minus 10. Do plus 10 to cancel that out. Plus 10 on that side is going to give me 9. And then our last step is to divide away that 2. So x is left alone on that side. And that will give us 4.5. Or if you'd like to, you could actually just leave it as that fraction, 9 over 2. Now remember, we can always check our solution. That 4.5 is what we think x is. If that's true, when you substitute x into this side and into this side, they should be equal to each other. So we're going to rewrite this. But in place of that x, we're going to put that 4.5. really just want to see if this side actually equals that side. You could do that by hand, but why do that by hand when we have Desmos? We might as well use it. We can't type in the entire equation. We're going to type in just the left side first. So 5 minus 2 times 3 minus 4.5. That equals 8. So when I substitute 4.5 into that side, it's 8. Now I'm going to substitute 4.5 into that side. And hopefully it also equals 8. Oops. So since I got the same number, when I substitute 4.5 in on both sides, that has to be true. Maybe a simpler way to do this is actually not even substituting it in by hand, just typing exactly what you see. So type exactly that, and then just tell Desmos, well, I think x equals 4.5. And it accomplishes the same thing. We see that 8 is the same on both sides. Alright, second example, I see that I could distribute on both sides. I have a number outside the parentheses here, and a number outside the parentheses there. So I'm going to distribute on this side, and I'm going to distribute on that side. 1/2 times 4 is 2. 1/2 times 10 is 5. Minus 20 is going to come down. 4 times x is 4x. 4 times negative 4 is negative 16. So that comes down as minus 16. And that plus 1 comes down. Once you distribute, we don't need the parentheses anymore, because that's telling us that really we're going to add and subtract in our next step. This doesn't have any like terms on that side. These two are like terms, so we can put those two together. The 2x doesn't change. 5 minus 20 is negative 15. This one doesn't have another x on that side. These two are like terms because neither one of them is an x. So we're going to do negative 16. Make sure you include that sign when you combine these. It's negative 16 plus 1. Oops, sorry. Negative 16 plus 1 is negative 15. So that comes down as minus 15. Whatever sign you get from combining them, that's the sign that shows up in that next line. Alright, now I want to combine my variables to one side. I'm going to cancel out this 4x. Right now it's a positive 4x that I have to cancel out. From before, you might be thinking, that's multiplication, so we have to divide. But we're not trying to just cancel out the 4. We're trying to cancel out the entire term. We're trying to cancel out a positive 4x. So you have to do minus 4x and minus 4x. This is not going to be affected by that. These have x's, so we can put those together. I can't do anything with this right now, so that minus 15 comes down. That cancels out. That gives me negative 2x. This cancels out. The only thing left on that side is that negative 15. Now it turns into a two-step equation, so I'm going to box this negative 2x and add 15 to both sides. Those cancel out. That's the entire goal of this. We're trying to get x by itself, so we're eliminating things on this side. So we have negative 2x equals negative 15 plus 15. That is 0. And then divide by negative 2 on both sides. That cancels out. We're just left with the x, which is, again, the entire goal. 0 divided by anything is just 0. So 0 is our answer. Let's check to make sure. I'm going to type exactly what I see. One half times 4x plus 10 minus 20. I'm just typing the left side. Then I'm going to type the right side. And then I'm going to say, I think x equals 0. And it turns out you get negative 15 on that side and negative 15 on that side. So x does equal 0. Alright, this one, it's the same kind of problem as we've seen where we have a big fraction here. We have an operation on top. Adding or subtracting is happening on top of the fraction. And we're dividing by a single number on the bottom. Whenever you see a big fraction like this, your first thought should be to cancel out that dividing. So we're canceling dividing. by doing the opposite of that. We're going to multiply by 3 on both sides. Dividing by 3 and multiplying by 3 cancel each other out. It doesn't affect this. They're just canceling each other out, so we still have 22 plus 4x on the left side. On the right side, you might be thinking we're not allowed to really do this because those aren't like terms. We can't add these together. Those are not like terms. But combining like terms really means that we're adding and subtracting. We can't combine these. That is as simple as that gets. But we're allowed to multiply. Remember, if we had something like this, you're allowed to distribute a 3. You can do multiplication between things that are not like terms. You can't do addition and subtraction between things that are not like terms. So you're allowed to multiply here to give us 15x. Alright, that's as much as I can combine on that side. There's nothing to combine here. So now I want to bring my variables to one side. I noticed I have 2 terms on this side, so I want to cancel out this x and bring it to that side. Right now it's adding 4x. I'm going to do the opposite of adding. We're going to subtract 4x from both sides. That gives me 22 equals 11x. One last step. That's multiplying, so we divide by 11. You should be used to that pattern at this point. That last step is almost always going to be the case in these problems. You have a coefficient there that you divide away. That gives us that x equals 2. Alright, the next one is a picture of an equation. We have 1, 2, 3, 4. Each of those is representing an x, so that's 4x. And then we have 1, 2, 3. Each of those is representing just a 1. 1, 2, 3, 4, 5, 6. Plus 1, 2, 3 x's. Alright, so that's our equation. There's nothing to really combine there. There's nothing to combine there. So I'm going to bring my x's to one side. I'm going to bring this to the other side by canceling out that adding. Those cancel each other out. That gives me just 1x plus 3 equals 6. Remember, 1x and x are the exact same thing. I'm going to get rid of that 1 because I really only have one step left. Right now, I want to cancel out that 3. I want to get x by itself, so I'm going to subtract 3 from both sides. That gives me x equals 3. I always like making sure that this actually makes sense in that picture. 3 plus 3 plus 3 plus 3 plus 1, 2, 3, that's 15. 1, 2, 3, 4, 5, 6, plus another 3, that's 9, plus 3, that's 12, plus another 3, that's also 15. Alright, we have a couple word problems. Centerville High School currently has 136 students taking orchestra class, and it's been increasing at a rate of 4 students per year. That phrase per year, that's telling us that there's multiplication happening there. It's multiplied by the number of years. Band currently has 200 students, and it's decreasing at a rate of 12 students, again, per year. That's telling us there's some multiplication happening there. If trends continue for both orchestra and band, in how many years will the 2 music programs have the same number? Alright, first off, what is the question looking for? It's looking for the number of years. So that's telling me that is where my variable has to be. That's going to be my x. So I don't know the number of years, and I just read that that's what we're multiplying by. Per year means times the number of years. That's what I don't know, so that means that's where my multiplication has to be happening. So I'm going to write 4x. Actually, before I do that, I'm going to write 136 just because that's the first number that I see. 136 increasing at a rate of 4 students per year. When are those going to have the same number? When is this orchestra class going to be equal to the band class, which starts at 200, and that one's decreasing by 12 students per year? I'm going to recap that one more time because that is a lot. Starts at 136, and it's increasing by 4 students per year. Oh, I messed up those colors. Sorry, that one should be red. Starts at 136, and it's going up by 4 students per year. this one starts at 200, and it's decreasing by 12 students per year. Starts at 200, and it's going down by 12 students each year. We want to know when they're going to have the same number. So we want to know when are those two things going to be equal to each other. That's why we put an equal sign directly in between. Right, now I can start solving it. I have an x on both sides, so I want to bring those x's to one side. I'm going to cancel out this negative 12x as my first step. I'm going to do plus 12x on both sides. That gives me 136 plus 16x equals 200. I'm going to subtract 136 from both sides. 16x comes down. That's the only thing left on that side because those canceled out. And that gives me 64. Last step is almost always the same. Divide away that coefficient because that's multiplying. So x is 4. Actually, I'm going to write x is 4 here and really answer the question here. How many years is really what I'm asked, so I'm going to say 4 years. So after 4 years, they're going to have the same number of students in the orchestra and bands programs. Example 6, a container A and container B have leaks. Container A has 800 milliliters and it's leaking 6 milliliters per minute. So it starts out at 800 and it's going down by 6 per minute. We want to know when will that container have the same amount. Sorry, I'm kind of jumping ahead of this. Container B has 1,000 milliliters and it's leaking 10 milliliters per minute. How many minutes, M, will it take for the two containers to have the same amount? Again, we're looking for when is this container going to be equal to that second container. That one starts out as 1,000, and it's going down by 10 milliliters per minute. So I'm going to add that 10m to both sides because I see it's subtracting 10m. So that's going to cancel each other out. Negative 6 plus 10, that's 4. Nothing else is really going to change. The 800 comes down. This is a positive 4, so that changes into a plus sign. The 1,000 is the only thing left on the right side. Now I have a two-step equation. I'm going to box my 4m, subtract 800 from both sides. Gives me 4m equals 200, and then divide by 4 for the last step to find out that m is 50. So it would take 50 minutes for those containers to have the same amount. Veronica solved the equation and got n equals negative 6. Is her answer correct or incorrect? So this is just the checking step here. So I'm going to type that exact equation in. Nope, that didn't work. Alright. And we're going to see if n equals negative 6. Well, this is not what I want. Alright, negative 4 times negative 2n minus 8. Just the left side, then just the right side. And we're suspecting that n is negative 6. But that is not true. Negative 16, negative 40 didn't give us the same answer. So her answer is incorrect after plugging in negative 6. Both sides are not really equal to each other. Always use the checking step if you can. Or always use the checking step. I don't know. You can always do it. It helps. And if there's a multiple choice question, there's also always the option to just take your answer and plug it in and see if you're correct. Hope this helps for the U-Try.